Then we also have something known as streak. So if we look at streak, typically we have two different color plates that we can use. And there's a reason for that, which I'll show you in just a moment. So we have a white porcelain plate and a black porcelain plate. So what we can do is we can actually test our minerals and check the color that they're actually, it's testing the color of the mineral powder. So you're scratching the mineral on the surface of the porcelain, which is very hard, and it breaks apart the edge of the mineral, and then you look at the color of the powder of that mineral. Now this doesn't work for every single mineral because some minerals are actually harder than the porcelain itself. So rather than scratching the powder from the mineral, you're actually cutting into the porcelain and scratching away porcelain powder. So you kind of have to be careful of that. But as an example, we can take a look at, say, this guy here, right? If I were to scratch it onto my white plate, obviously we can barely see that. If you hold it at an angle, you can kind of see that it's there. So typically white on white or a lighter color on white is not going to show up too well. That's where a black plate comes in. We can actually give that a good scratch. And then we can actually look at the color of that streak, all right, which comes out quite white with maybe a touch of yellow. And of course, looking at our mineral kind of fits that category. However, don't be fooled because there are some minerals that may produce a different result than what you're expecting. Okay, so one example of this, if we wipe this one off, I can take this mineral here, we can see that it's kind of a reddish brown, and if I were to streak it, we end up with a reddish brown streak. Although, since this and this are the same mineral, what color do you think that this mineral is actually going to, what color is going to be the streak? Right, this one turned out to be reddish brown, but it's also a reddish brown color. So looking at the color of this, we can assume that it's going to be a gray or a black or kind of metallic grayish color to it, right? So if we come down here, we start scratching. And I don't know if it's kind of hard for you guys to tell at this point. It's not the same exact color, but this is actually kind of a reddish brown. All right, it's kind of a reddish brown color. The camera's not picking it up too well, but in person, it is definitely, this one's definitely much more red compared to this one. But this one has a very distinct reddish, like dark red brown color. Which is not what I would have expected from something like this, something so pretty, right? And even on the end of that mineral, you can kind of see this reddish brown color from me scratching it. All right, there is also something known as the hardness test, and the hardness test actually specific minerals are a specific hardness. So some minerals are harder than others. One example might be taking a mineral and you're actually able to sit here and scratch it with your fingernail, and you end up with powder on your finger. So we know that this one is actually less hard than a fingernail. So we can actually rate that on a scale from 1 to 10. Now if we were to go over to, say, something a little bit different, maybe like this guy here, and I sit here and try and scratch my finger on that, there's no way I'm going to scratch that, that guy. I'm actually probably destroying my fingernails in the process. So we can use other materials to test on it, right? We can actually take, say, some copper, a copper penny, and we can take it and scratch it, right? And then you can see that this easily scratched, kind of gouged the penny. All right, so I know that this is harder than copper. So we can move up to something like an iron nail. All right, this is a soft iron nail. So then I can actually take this and try and scratch it, or scratch the mineral. All right, the nail's doing nothing to this thing. And as a matter of fact, when I scratch it on here, it's taking away bits of the nail. So I know that even still, this mineral is harder than a nail. So I can move it up even more. We can go to something like a hardened steel object, like a file, right? So then I can take that and I can scratch it on there, and I can tell right away that this is actually destroying the file. So this is even still harder than a steel file. So then you can kind of continue on up the scale, right? We can take a look at our streak plate. Our streak plate is actually harder than steel. So we can take this and scratch it, and I'm not really scratching my plate. So therefore my porcelain's harder than this. So I know that my hardness sits between the hardness of porcelain and the hardness of a steel file. So my mineral would sit here in between the porcelain plate. So it's softer than my porcelain plate, but harder than steel. We also have something known as specific gravity, which is just a fancy word for saying density. So how dense a mineral is. And we can actually test that by, if we suspend it in water, all right, in a cup, we can actually figure out how much the volume has changed and work out the mass of the object or the mass of the mineral and divide that by our volume in order to figure out our density, also known as specific gravity. So you can also work that out that way. There's also textures as well. So how do they feel? Are they smooth? So as an example, I'm feeling this one here. It's actually quite kind of silky smooth. Obviously we have other ones that are much more rough, and however you can describe the texture of the object, right, compared to others. And then there's also one last section known as special properties. So special properties include things like double refraction. Double refraction is a good example of when you were to take something, and when you place it over top, you can see that it actually causes a doubling effect of whatever is written down, right? So if we look at that number 1 there, you can see that it is turned into an 11. So this is known as double refraction. We have something known as effervescence. Effervescence is when you actually take a mineral and you put acid on it, and the acid will bubble and eat away at the mineral. And in some cases actually cause some fumes or smoke to be created. There's also other things like magnetism, right, where you can actually take a magnet and go around and work out which ones are magnetic or not, and then, right, figure out kind of based off of a property such as that. There's also something known as iridescence and fluorescence. Iridescence and fluorescence, this is probably not going to show up too well, but you can use a black light and shine it around on different minerals. Some minerals are going to fluoresce and change into different colors over others. All right, other ones do not have that capability. All right, so that's a breakdown of how we test minerals in order to help us identify them. The next part is going to include some more information on the specific minerals that you're going to need to be able to identify based on specific properties of those minerals. And we'll take a closer look at them. All right. See you in the next part.